Welcome back to today's class, children. Today we are going to discuss about the electrons which are distributed in the different shells, that is according to the Bohr and Bury scheme. What are the rules to be followed when you are writing the number of electrons in the different energy levels? The first one is the maximum number of electrons present in the inner shell is given by the formula 2n square, where n is the orbit number or energy level index, that is 1, 2, 3. So when you substitute in place of n as 1, the first orbit, that is K shell, it will accommodate 2 electrons, that is 2 into 1 square, that becomes 2. The second orbit or the L shell will have 2 into 2 square, that is 2 square into 2 is 8. The third orbit or M shell can accommodate 18 electrons, and the fourth orbit or N shell can accommodate 32 electrons. The maximum number of electrons that can be accommodated in the outermost orbit is 8. It must be 8. The electrons are not accommodated in a given shell unless the inner shells are completely filled. So when the inner shells are completely filled, then only the electrons will jump into the next shell. So these are the rules to be followed when you are writing the number of electrons in different energy levels. This is the atomic structure of certain elements, children, that is in the first periodic. The first one, what you can see is hydrogen, where in the first orbit it has accommodated only one electron. The second element is helium, that is the inert gas element which has 2 electrons. Okay. Then third element is lithium, 3 electrons, 2 in the first orbit, first shell, and 1 in the second shell. And then comes the carbon. The atomic number of carbon is 6. So 2 electrons in the first shell and 4 in the second shell. Then comes the fluorine. Fluorine is having the 9 electrons. It is the ninth element. So 2 electrons in the first shell and 7 electrons in the second shell. The neon, this is also an inert gas element which has the atomic number as 10. So 2 in the first shell and 8 completely filled, that is in the second shell. So here we have the neon, that is the inert gas element whose outermost shell has 8 electrons. Then in the third period we have sodium. The atomic number of sodium is 11. So 2 in the first shell, 8 in the second shell and 1 in the third shell. Okay, then comes the silicon. The silicon has 2 electrons in the first shell, then 8 electrons in the second shell, and then 1, 2, 3 and 4 electrons in the third shell. Okay, coming to chlorine, the chlorine is 17. So 2 in the first shell, 8 in the second shell. So 8 plus 2 is 10 and 7 will be there in the third shell. Then comes the argon, which is the nearest inert gas element, which has 2 in the first shell, 8 in the second shell. So 8 plus 2 is 10 and again 8 in the third shell, that is 18. So any atom which has 8 electrons in the outermost shell, they are called as the inert gas elements which are highly stable. So this is the periodic table, children, where you have all the 118 elements, and in this 118 elements there are 6 elements which are inert gas elements. The first one, let us just read the 20 elements in the periodic table. The first one is hydrogen, second helium, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, 9 is fluorine, 10 is neon, 11 sodium, 12 magnesium, aluminium 13, silicon 14, phosphorus 15, sulfur 16, chlorine 17, argon 18, then 19 is potassium and 20 is calcium. You can see to the right corner, children, in a blue color box. So that is the second element helium, the 10th element is neon, 18th element is argon, 36th element is krypton and xenon is 54, radon is 86. So these 6 elements are nothing but the inert gas elements which are stable. So here you can see the atomic structure of the noble gas. The inert gas elements are also called as noble gas element. The first one picture what you can see is krypton, which is 36. Okay, so in the outermost orbit they are completely filled. So how you will get 36 is 2 in the first orbit, then 8 in the second orbit, again 8 in the third orbit. So 8 plus 8 plus 8. So 8 3 is 24 plus 2. 24 plus 2 is 26. So 26 plus, you can, if you take it as the 8, so it becomes as krypton, that is 36. Okay, so the second one is 86, that is radon. Then the third picture what you can see is neon, that is 10. So 2 in the first orbit and 8 in the second orbit. Then xenon, it is 54, and argon, it is 18. So 18 is 2 plus 8 plus 8. So these are the atomic structure of the noble gas elements. Now let us move on to the next one, that is valency. So what is a valency? The electrons present in the outermost shell of an atom are known as valence electrons. So when the electrons which are present in the outermost shell, that electrons are called as valence electrons. So according to the Bohr-Bury scheme, the outermost shell of an atom can accommodate a maximum of 8 electrons. So according to the scheme, the outermost shell can accommodate a maximum of only 8 electrons. The atoms of elements having a completely filled, the atoms of elements having a completely filled outermost shell show little chemical activity. Means in the outermost shell, if they are completely filled, that is with 8 electrons, if they have, those atoms show little chemical activity. They will not show more activity. They show only little chemical activity. Hence, their combining capacity or valency is 0. Can you understand, children, what is this? Once again I will repeat. The atoms of elements having a completely filled outermost shell, means in the outermost shell if there are 8 electrons, so such atoms of elements show little chemical activity. So since it is showing little chemical activity, their combining capacity or valency becomes 0. When you talk about the second element, helium, a helium has 2 electrons in the outermost shell. Okay, helium will have the 2 electrons in the outermost shell, whereas all the other elements have their atoms with 8 electrons, because the next of the helium, we have the next inert gas element as neon. So where it is 10, so in that 2 electrons will be accommodated in the first shell and 8 electrons will be accommodated in the second shell. So except helium, remaining all the other elements, that is inert gas elements, they have the atoms with 8 electrons. So an outermost shell which had 8 electrons was said to possess an octet. So you call that configuration as octet configuration. So the outermost shell which is having 8 electrons is known as octet. So this was done by sharing, gaining or losing. So how do you get that 8 electrons? Either by sharing or by gaining the electrons or by losing the electrons. So the number of electrons gained, either lost or shared, gained, lost or shared to make the octet, to make the electrons to become as 8 in the outermost orbit, gives us directly the combining capacity of the element, that is the valency. Okay, the number of electrons gained, lost or shared to make the octet gives us directly the combining capacity of the element, that is the valency. So therefore an atom of each element has a definite combining capacity called its valency. If you take oxygen, oxygen is the 8th element. So what will be the number of electrons in the outermost orbit, children? So the first orbit will have 2 electrons. The second orbit will have only 6 electrons because it is 2 plus 6. It becomes the 8. But according to the scheme, to be stable, the outermost electrons, the outermost shell must have 8 electrons. So what the oxygen will do is, the oxygen will gain. It gains 2 electrons to get the inert gas, or it needs electrons to get the nearest inert gas configuration, that is the neon. So since it is gaining the electrons, you write with the charge as negative. So you write it as O2 minus. So what is the valency of oxygen? The valency of oxygen is 2. Okay children, so here when you one more example when we take, so sodium, let us take sodium. Sodium is a 11th element. So what will be the outermost shell? How many electrons will be present in the outermost shell? Only one. So how? Yes, in the first orbit it will be 2. In the second orbit, that is in the p orbit, it will be 8. So 8 plus 2 is 10. In the third shell, it will have only 1 electron. Okay, so what sodium will do is, the sodium will lose 1 electron to get the neon. Okay children, so that is why, since it is losing an electron, you write it as Na plus. So what is the valency of sodium? The valency of sodium is 1. Okay children, but there are some exceptional cases like fluorine. Instead of fluorine, when we take, fluorine is a 9th element. Okay, so when it is 9th element, you have 2 electrons in the first shell, and 7 electrons will be in the second shell. Okay, so according to this scheme, how many electrons are present in the outermost shell only, we will be writing it as valency. So we are writing the valency of fluorine as 1 children, instead of writing it as 7. Why? Because to lose 7 electrons, it is difficult to lose 7 electrons. Instead of losing 7 electrons, it can gain 1 electron. Okay, to get the inert gas configuration. So that is why the valency of fluorine becomes as 1. Okay children, so therefore an atom of each element has a definite combining capacity called its valency. So valency is nothing but the number of electrons which are present in the outermost orbit, either by gaining or sharing or losing. It tries to get the octet configuration. So how many electrons are gained or shared or lost, so that gives its valency. So valency is nothing but the combining capacity of an element to get the octet configuration. So hope you have understood children about this, that is Bohr-Bury scheme, the number of electrons present in the outermost orbit, and what is its valency, what are valence electrons. So read the textbook for your better understanding. Thank you. Have a great day.